Here we go. Proofs 101. Definitions, theorems, postulates, and properties. We're going to look at angles, perpendicular lines, right angles, linear pairs, and angle bisectors. We're going to look at substitution and transitive properties, and linear pair postulates, right angle congruence theorems, vertical angle theorems, and congruent complements and supplements theorems. Well, let's start out with angles. So, if you look at the right angles here, these are the same side interior angles. Looking at this as a transversal, cutting into these two lines. So, same side interior angles being the same side of the transversal and on the interior of the two lines. Same side exterior is pretty much the same thing. On the same side of the transversal, 8 and 2, but on the exterior of the two lines. Alternate interior angles, like 4 and 5. I didn't do a great job with color coding these, but just make sure you have the right angles here. So, alternate interior angles, meaning they're on different sides of the transversal. 4 is on the right and 5 is on the left, but still within the interior of the two lines. Same with the alternate exterior, like 2 and 7. And the corresponding angles are angles that have the same position relative to their little group of 4 angles. Like, this group is 4 and this group is 4. So, an example of a corresponding angles would be 7 and 3. They're both on the bottom left-hand side of their group of 4. And the deciding factor for what angles are what is their position relative to the transversal and the two lines that intersect. Okay. Perpendicular lines and linear pairs. So there's your linear pair. I totally forgot what the exact definition is, but it's like a ray and a line that intersect at a point, which here or something. I don't know. It looks like that. So, according to the definition, angles. Where is my mouse? Here we go. Angles 1 and 2 are a linear pair. There you go. Here's my perpendicular lines. If two perpendicular lines intersect to form 4 right angles, so 1, 2, 3, 4. So by that definition, angle 1 is a right angle. And that also states that the definition of a right angle, the definition of a right angle states that all right angles are 90 degrees. So if angle 1 is a right angle, that means angle 1 is also 90 degrees. Angle bisector. Here's my lovely picture. So this picture, ray AB is bisecting angle SAT. An angle bisector splits the angle into two congruent adjacent angles, adjacent meaning next to each other. So therefore, angles 1 and 2 are congruent. Properties. Really, the only two properties used in geometry proofs are transitive and substitution property of congruency and or equality. Putting trans or sub should be acceptable. And to put in simple language, substitution is used when the connecting description is different. For example, if you are given that angle 1 and angle 2 are complementary, and angle 2 is congruent to angle 3, you can say that angle 1 is complementary to 3 through substitution. It's substitution because you're using complementary angles, and congruent angles, which are two different connecting what's-my-geez. But when all the angles are connected through congruency, the transitive property would be better. So if angle 1 is congruent to angle 2 and angle 2 is congruent to angle 3, you could say that angle 1 is congruent to angle 3 through the transitive property. Linear pairs and right angles. So all right angles are congruent, and that's pretty much all the right angle theorem is. There's a linear pair again. Let's see, so linear pair postulate is different than a definition. The postulate states that all linear pairs are supplementary, meaning they're 80 degrees. So when you're writing proofs, you would say that angles 1 and 2 are linear pair, and they are supplementary, because if they're a linear pair, then they're supplementary, not the definition. Okay, vertical angles, they're pretty boring. Okay, vertical angles are always congruent, so in simple language they are across from each other. Here and here. They're pretty easy to spot, so therefore angles 1 and angle 2 are congruent. Supplements and complements. I really don't have any diagrams for this. So this pretty much says that supplements and complements of the same angle are congruent. So if 1 is complementary to 2 and 3 is complementary to 2, then 1 and 3 are congruent. Same goes with supplementary. And just for a refresher, sums of complementary angles equal 90 degrees and supplements equal 180. Stay tuned for part 2 where I actually teach you how to do proofs. I don't know what that'll be. But thank you for watching. Yeah.